Good evening, boys and girls. Welcome to another lesson on Technical Sciences, grade 12. You are with me, Mr. Sibanyoni, and I am going to take you through another lesson online. We are continuing online again, with Technical Sciences, grade 12, and we are still focusing on light. So we did that yesterday, and I really think the lesson went very, very well yesterday. So today we will be looking at the different section of light, so that by the end of the week, we have done everything that we need to know on light as per the examination guidelines. Are we together, my dear learners? So that is very important. And I'm also trying to be as slow as possible and give you tips on how we are going to ask you questions in your examination at the end of the year, which is very, very near altogether. So I really hope that you are preparing thoroughly. My other hope is that you are definitely studying technical sciences and you are revising, and that is why you are actually viewing and joining these particular lessons. So let us look at the structure of the lesson for today. We will quickly revert back into light as per the examination guidelines so that we see what we are required to know in terms of this section of the work. And then in the features of the topic, we will be learning light. And in particular today, we will be focusing on total internal reflection. And then we will do questions on light as well. And in particular, it will be questions on total internal reflection. And I will be giving you more tips in terms of examination preparation and mark allocation for this particular topic. So my dear learners, please let us get into it and enjoy the lesson. Right. I hope you have a paper and pen ready and you will be taking down notes. Now, as per the examination guideline, remember, and today we are using a purple pen. Yesterday, in our lesson, we've learned these definitions: the definition of a wave, the definition of reflection, and the definition of refraction, which is what we are supposed to know as well in terms of examination guidelines. So you must note, my dear learners, that the definition of a wave is important, and we said it is a disturbance that transfers energy through matter or space. Very critical. This disturbance, this vibration that is taking place, it does transfer energy, and it's through matter or through space. And I've reminded you that when we say through space, we are talking about a vacuum. In other words, a space that does not contain any form of matter. So light in itself, my dear learners, it means it can transfer energy either in a space that has matter or in a space that does not have matter. So it is a disturbance and it does transfer energy through matter or space. Then we learned how to define the term reflection. And we said it is the change in direction of a wave. And my dear learners, you will note that it doesn't end there, because we explained further, when does it change the direction? So we said it's the change in direction of a wave upon striking the interface between two materials. And that will be for 2 marks, the same as that. It is definitely 2 marks. So I said what the reflection is, and it must encompass when does that happen. So the change in the direction of the wave occurs upon striking the interface between two materials. And then we have refraction. And we say refraction is the bending of light when it passes from one medium to another. That's 2 marks. Can you see this definition also? Just like reflection, it explains what refraction is, and in that, it explains when does it happen. So it's the bending of light when it passes from one medium to another. And I am sure by now you know the difference between reflection and refraction. With reflection, when the light changes direction, it reflects back into the original medium. If it was striking, for example, a mirror and it was coming through air, then when it is reflected, it goes back into air after striking the interface. But with refraction, the light will bend, but if it was from air, it won't go back to air because it's not reflected. It is refracted, so it will bend and it will bend into another medium. And we will recall here as well, my dear learners, that when it bends into the second medium, it can either bend towards the normal or away from the normal. And I really just want to take time to talk about this one. When does it bend towards the normal? It depends. We said for the light to bend towards the normal, the light ray must be coming from a less dense medium to a more dense medium. Or in other words, for the light to bend towards the normal, the light must be coming from a medium of lower refractive index to a medium of higher refractive index. Very critical, my dear learners. Remember that. And we know again, when this light is bending and it is moving towards the normal, it tells me that where it was coming from, which is a medium of low optical density, the speed was high, and now when it enters the second medium where it will travel, the speed will be low, it will decrease because it was moving from a medium of low optical density to a medium of high optical density. That is that. Sometimes this light, we say it will bend away from the normal. When does light bend away from the normal? For example, when it goes from the glass into the air. So it is moving from a medium of high optical density to a medium of low optical density. So it will bend away from the normal, from glass to air. In other words, it is moving from a medium of higher refractive index to a medium of lower refractive index. As a result, the speed as well is going to increase because in the medium of higher refractive index, the light rays are traveling slowly, but in a medium of lower refractive index, the light rays are moving faster. So we are going from high speed to low speed, and that is why we say the speed is decreasing. So remember that, my dear learners, and hence it bends away from the normal. And then we also learned the laws of reflection and the laws of refraction. Now, I want to emphasize this, my dear learners. You see there, the laws of reflection and the laws of refraction, they are not stated, but you are supposed to know them. It's part of the content. It's recall work. So you must remember. And I said this laws of reflection and the refraction, it's 2 laws each. And for the law of reflection, I'm just reminding you here, my dear learners, you must state 2 laws. One law talks about the relationship of the angle of incidence and the angle of reflection. The second law talks about the incident ray, the normal, and the reflected ray. So let's talk about the first law. The first law of reflection says the angle of incidence is equal to the angle of reflection. Secondly, it says the incident ray, the normal, and the reflected ray all lie on the same plane. So those are the two laws, and it's 2 marks. And then we talked about the laws of refraction. And I want you to see this. It has the same basis as the laws of reflection. It's just that it now explains refraction. Now, what does it say? It means it will also talk about the relationship between the angle of incidence and the angle of refraction. And secondly, it will talk about the incident ray, the normal, and the refracted ray. So what does it say? Let's talk about the angles. It says there is a relationship between the angle of incidence and the angle of refraction when the light passes the boundary from one medium to another. Secondly, it says the incident ray, the normal, and the refracted ray all lie on the same plane. So very important, and here we use refracted ray because we're talking about the law of refraction. Now, I wish to indicate some of the mistakes that we observe at the marking center. Is that some of you learners, you will say the incident ray, the normal ray, and the refracted ray all lie on the same plane. And now when you talk about the normal ray, it becomes incorrect because the normal is not a ray. It is simply a line that we draw perpendicular to the surface altogether. So don't talk about the normal ray, we talk about the normal. So that's what we talked about. And we drew ray diagrams and we labeled them. And I told you, very critical for you to be able to do that. Now, we are going to learn about critical angle today and total internal reflection. And you must know how to define this angle, and we will ask you this. The critical angle is the angle of incidence in the denser medium. This must be there, is the angle of incidence in the denser medium. Now, my dear learners, I know some tend to confuse this and say, you're asking me for a critical angle and you say it is an angle of incidence. Yes, my dear learners, a critical angle is actually a special type of angle of incidence. It is still an incident angle. It's just that we refer to it as a critical angle. If it were possible, we would say it is the critical incidence angle, but we don't say that. We just say critical angle. And I want you to see why we say it's a special type of angle of incidence. Firstly, it's an angle of incidence and it must be in the denser medium, and you need to specify that because you won't get a critical angle in a less dense medium. It will be in the denser medium, in other words, in the more optically dense medium, such that the refracted ray, so we will still have refraction, so we'll still have the refracted ray, and that refracted ray will just pass through the surface of separation of the two media. So I will show you that if the angle is a critical angle, it's that angle which will then make the refracted ray to lie on the surface of separation of the two media. And another concept which we will learn later about, it is dispersion, which we will also define. And it is simply the phenomenon whereby light breaks up into its component colors. So we're not doing that today. We are actually going to deal with that tomorrow. And then we must be able to discuss the following: the laws of reflection, the laws of refraction. We are able to do that. And for today, my dear learners, we will be focusing on this total internal reflection. And we say a definition for total internal reflection is important. And we say it is when the angle of incidence is greater than the critical angle, the ray of light reflects into the original medium. So we will talk about this, but you will remember when we talked about the critical angle, we said is the angle of incidence in the denser medium such that the refracted ray just lies on the surface of separation between the two media. Now, if you want total internal reflection, it means you need to increase the incidence angle such that it is actually greater than the critical angle. And that is when the ray of light will reflect into the original medium. So the definition says, when the angle of incidence is greater than the critical angle, the ray of light reflects into the original medium. Very important. We will discuss the conditions of total internal reflection, and we will state the uses of total internal reflecting prisms altogether. And you must know at least 2 uses. At most, we will ask you for 2 uses. So very important for you to be able to work with this. And later on, which will be Thursday, we will be talking about lenses. When we talk lenses, my dear learners, we will discuss the frequency and the wavelength of the various components of light. We will discuss and we will draw transmission of light through convex and concave lenses. So we will be dealing with objects that give off light rays, and the light rays passes through the convex lens or a concave lens, and we will check how an image is formed altogether. So we will be drawing a lot here. Then we will discuss the applications of convex and concave lenses. This is where we'll talk about the usefulness of these lenses altogether. For example, for people who are far-sighted, meaning we have hyperopia, or what we call hypermetropia. Their lenses are made up of convex lenses, and people who are short-sighted, their lenses are made up of concave lenses. We will be talking about those things. So these lenses are very much useful to us. Again, we must then give the properties of images that are formed by these lenses. So the concave lens as well as the convex lenses. Furthermore, my dear learners, we will be required to know also the properties of the lenses themselves, the concave as well as the convex lens. So that is very critical, my dear learners. Right. So we continue with what we are basing our lesson on today. Now, let us talk about the critical angle altogether for this section of the work. Now, before we do that, I want us to just look at basic refraction. So here I have a ray, right? And this ray, I will call it the incident ray. Now, I can see that this ray is moving from, let's say this is made up of glass, this medium, it's glass, and this medium is air. Now, with glass, I know that glass is more dense. It's a more dense medium. And I know that air is less dense. Now, what do we know, my dear learners, is that when light moves from a denser medium, right? A medium which is more dense to a less dense medium.